I think we're good right now, so I'm going to begin. All right, so welcome to the last day, to the last session of Build 2013. Who's excited? Who's still excited? So I know you guys are recovering, so I will try to keep this easy on you guys. There's a lot of information here, but I feel like when you leave this session, you should feel confident that you know how to scan from your app. So, excuse me. My name is Monica Charney. I'm a Windows Program Manager on the Devices and Networking team, and I will be talking to you about how to build Windows Store apps that incorporate image scanning. So, Windows 8.1 is introducing scan support. So why would you incorporate scanning in your app? I'll let you know which devices you should expect to work with your app. I will go through and show you the new scanner namespace and describe the properties. And then I'll actually show you some demos with the scanner device here, as well as we'll dive into some code snippets in Visual Studios. I'll show you how exactly that's done. Okay, so let's back out for a second. So it's 2013. We live in a very digital world. So we share photos, we share documents, we share video and audio. That's how we spread ideas. We can archive content and images. So in this way, we build a digital history of our work, our interactions, and our creations. So we can modify text, and we can modify images. So we can actually do more than just pass around raw data. We can actually extract information from content, and from that we can build intelligence. We can do some really interesting things. So if you guys saw the keynote on our first day, there was some really great image text recognition, optical text recognition that you guys saw there. So essentially, since these things are available, users have come to expect experiences, they expect information, and they expect intelligence to be built from that information. So here in the physical world, there's a lot of content being left behind. We all have physical documents, we have forms, we have receipts, and these have all accumulated in our lives. This content is being left behind, and it can't take advantage of the richness of the digital world. So we turn to peripheral devices to actually digitize content. So cameras are really great for digitizing on the go, but scanners are optimized for bringing high-fidelity images at high resolutions without reflections, distortions, or shadows. And there's actually a lot of scanners out there. We have third-party market research telling us that 66% of all the printers that are connected to Windows today, they also have scanners. So we call these types of devices multifunction printers, MFPs for short. That's the term I'll be using today. So they typically have a glass panel, like a flatbed. Let's show you guys. And then an automatic document feeder here, which allows a user to place a set of papers on there, and they can be scanned in more than one page at a time without manual intervention. So this technology has been around for decades now. We've been talking about the paperless office for many years. Why is content still being left behind? Why is there such a disconnect? Why aren't users scanning every single thing that they have? So for a user to initiate a scan job, there has to be a great experience around scanning. So there has to exist an app or a service or a workflow that provides the sharing, archiving, modifying, or extracting capabilities that allows a user to accomplish whatever goals they might have. So if the experience or workflow is convoluted, usually these things are being left in the physical world. So Windows 8.1 is introducing scan support to enable a successful handoff. This allows the device to be part of your app. Your app is now responsible for how scanning looks and feels to the user. Your app is now part of their workflow. So we are enabling this with the new Scan Runtime APIs. And these are actually built on this massive support that is the Windows Imaging Acquisition Platform. consisting of the COM API, kernel mode services, or kernel mode drivers, and core services. So the new Scan Runtime APIs can both scan from the Windows Store and from desktop environments. So those that are familiar with WIA, those familiar with the pain points of WIA, it's that power and stability that the Windows runtime is built on top of. So if you haven't heard of WIA, you don't need to know anything about the underlying platform to just dive in and start building immersive apps for your users. So say you do two things. So if you make your own scanners, if you saw Dean and George's talk in session 23, they told you exactly how your device can download an app so that you can create a signature scanning experience for your particular device. If you are a general app developer, you can use the breadth of devices that Windows supports. So the new Scan Runtime APIs are compatible with certified WIA 2.0 drivers. Okay, so what does this mean? So Windows has you covered. Windows has you covered with great inbox support. So inbox, we support more than 500 scanners, with many more available on Windows Update. So inbox, we're able to support all network scanners with a inbox class driver. So you should be confident that your app will work with the majority of devices available in the ecosystem today. So we'll actually dive in. We'll show you exactly the function calls required to enable scanning in your app. And it's actually very, very simple. I wanted to emphasize how simple it is by representing it with 3 steps. We're going to enumerate the scanner devices, we're going to get the scanner object, and then we'll actually scan. So there's actually 2 optional steps that you might want to take. If needed, you can set additional scan settings on the device, and you can actually do a preview before you initiate a scan job. All right, so I will jump into the namespace right now and show you how you can set scan settings. So the new Windows Devices.Scanners namespace has the image scanner class. And this class is the core of our new API. It encompasses everything you'd want to do from setting up the device and up to actually retrieving images from the device itself. It supports 3 different configurations: auto-configured, flatbed, and feeder. So the auto-configured is a special scan source. It will allow the device to set the best settings for the device itself, and your app is only responsible for setting the format setting. For flatbed, this represents the common settings that are available, so you should know at most what to expect from every single device you might encounter. The feeder scan source supports additional properties that have been available for the auto-configured and the flatbed sources. So scanners are super powerful and they're complicated, but you should feel like you know what to expect from every device you will encounter. So we'll actually jump into the demo at this point. We're going to enumerate scanners. We're going to scan from the 3 different sources. Then we're going to set some settings on there, as well as handle progress from the scanner. All right, so these are the Scan Runtime API samples. These are available on MSDN, and they're available right now for you to look at and use. So on the left-hand panel, we have a list of scenarios we'll be running through. And then I'll jump into Visual Studio, and I'll show you the exact function calls it takes to make these happen. OK, so the first thing we're doing is we're enumerating our scanner devices. You can see here it's detected a particular device with a name and an ID. And that makes sense because I'm plugged in with a USB cable. So let's show you how that works. So to enable this, we're using the Device Watcher. And this is outside of the new Scan Runtime APIs. This is within the Windows.Devices.Enumeration namespace. and this can be easily extensible to other device classes. So we'll create a device watcher called Scanner Watcher. Oops. And as you can see, we're creating a watcher called Scanner Watcher for image scanner devices. So you can do this for different types of device classes here. So what it does, it dynamically looks out for scanners as they're added, removed, or updated. And to be able to handle this, we add event handlers. So when a device is added, we created an event handler on scanner added, and that gives us a device information object. And that consists of what you saw earlier on the screen. That's the ID represented as a GUID and the common name of the device. So since this is done asynchronously, we'll want to call it core dispatcher to bring it to the main UI thread. And you can just add it to your list of current devices, which you can either do in a combo box or a stack panel. So that was how we enumerated devices. All right. So the next thing we'll want to do is actually scan using the auto-configured scan source that I mentioned earlier. So we're going to start our scenario. So as it's scanning, an important thing to note that since I didn't put anything on the tray here, it did not scan from the feeder, it scanned from the flatbed. And the image is displayed here, and it's been saved to the My Pictures library with this file schema. So there are two important things you need to do to enable successful scan. You need to know the location at which you want to save the files to, and that device ID. Okay, so since we're saving to a local user's resource, the My Pictures library, we have to declare this in the apps manifest as a capability. So I want to show you how we got that done. Okay, once we click Start Scenario, we have our function that we created here. It's called Scan to Folder. It takes the currently selected scanner's ID, that was that GUID that we saw earlier, and that destination folder, which is the My Pictures library. So first we get the scanner object for that device ID, and we're going to call from ID async to get the scanner object. We're going to call it My Scanner. Okay, and at this point, we have just directly got the image scanner object, and from then on, we can actually jump in and make a scan. Or if needed, we can set scan settings on that device. And this is all done through that image scanner object that I mentioned earlier. That's the core of our API. So before you actually want to do a scan job, you're going to want to make sure that the actual source is supported. So we'll do that real quick. Oops. And in this case, we're scanning from the auto-configured scan source. And here we'll actually scan. So we will return a result, and result will be a list of scanned files. So by calling scan files to folder async, it takes the source at which we're scanning to and the folder. And those are the two parameters that you need to directly scan to that folder. And that's it. You're expecting more, but that's pretty much it. That's all we needed to do to set up to actually scan to a folder with a list of files represented in the result here. So I'll show you how to do a preview real quick, and that should work very much the same as a scan job. Okay. So a preview is basically a low-resolution scan that is performed very quickly. that is not saved to a destination folder. It's basically displayed on the screen for a user. A user might want to do a preview if, as a visual confirmation, if they want to scan to a smaller sized area, if they're scanning at a higher resolution. So it's basically a preview before a user initiates a scan job. And this works very similar. Instead of passing in a folder, we're going to pass in a stream object at which the device scans to. So it works very much the same upon our click. Oops. Okay, so we have scan preview here. We pass in a stream object instead of a folder. We're going to get an image scanner object by calling from ID async with our device ID. We're going to make sure that previewing is supported on the flatbed, and that flatbed is supported as well. And then we're actually going to do a preview. And that was it. So the preview is being done with whatever default format. You can set the format at which you scan to, and this directly scanned to a stream object. And that was it. That's all we needed to do to create a preview. And the result should let us know whether that has succeeded or not. Okay. So let's just say that we want to actually scan from that flatbed, and we want to scan at a smaller scan area at a higher resolution. I'll show you how we do that. So as before, you guys should be pros. You should know what this looks like. We're going to want to get the scanner object for that device. Then we're going to make sure that the flatbed is supported as well. So we create a smaller scan size by representing that as a rectangle. So here we're going to modify the size that we scan at. My scanner. Okay, so that new region will be a rectangle with the coordinates of 0, 0, 6, and 4. Actually, we'll make that, since we have that bulletin that's displayed right here, we want to just scan that area. And so we want to change the resolution of that scanned image. And the way that we do that is the device itself does not represent all of the resolution supported. It reports to us the minimum, the maximum, and the optical resolution. So whatever resolution you choose to scan from, if you're scanning documents, it doesn't really make sense to scan at a much higher resolution than, say, 600. So we want to see if that's supported for my device. So we'll create a resolution object. Oops. So we create a resolution object, and that has X and Y dimensions. So we set the desired resolution as the resolution, and the device itself will give us back the actual resolution. And that will snap to the closest supported resolution for that device. And we'll represent it as a string. I don't know why my auto is not working. So we'll actually represent that down here. All right. And as before, we will scan to that folder from the flatbed scan source. So let's go ahead and see what that looks like. taking long. Okay, so this image was scanned at a smaller scan region, and we scanned it at a much higher resolution at 600 dpi. So, and this was actually supported by the device since it represented the actual resolution as 600 dpi. So for the last demo, I'll show you how to scan from the feeder, and you should probably know exactly what this looks like. We're going to change the scan source to make it to scan from the feeder instead of the flatbed. And everything else looks the same. In this case, we'll change some of the device settings to show you how it looks like to interact with that device. Okay, so first thing we do is we grab the scanner object for that device. As before, we call from ID async. Make sure that that scan source is supported. So we want to scan at a different file format than the format that is supported by the device itself. So if that device does not support that format, your app can supplement its functionality by doing any type of post-processing for it. So we're going to check to make sure if the Portable Networks graphics format is supported, we'll scan to it. If not, we'll continue scanning from the bitmap format. If your app wants to reduce the size of that image, we can scan to a different color mode. So we check, make sure is grayscale supported. If it is, we'll scan to grayscale. If this device supports scanning both pages or both sides of a page, we'll also enable that. And lastly, we're going to want to scan all the pages that are available on that feeder. And so we'll set the maximum number of pages to 0. Okay. So in this case, we want to show progress. We want to show each file as it's being scanned. And we'll actually just show the number of files that have been scanned so far. So we'll create a progress handler called scan progress. And that will basically show us the number of files that have been scanned so far. And we additionally have a cancellation token that will allow the scan job to be canceled. So as before, we call scan files to folder async, choosing the image scanner scan source as feeder. And this time, we're going to run it as a task that shows progress and is cancelable. Okay. And I will actually put some papers on the flatbed here and start the scan. Okay, so an important thing to note is that when you actually begin your scan job, when you call scan files to folder async, your app must be visible and in the foreground. So you cannot initiate a scan job while your app is being suspended. Additionally, we've done some work with the process lifetime management of the app. So that means that the scan will continue if your app is suspended. So the scan job will continue and it will complete. So it's up to your app to register notifications or toasts letting you know that your scan job has completed and to return back to your app. So here's the list of scan files, and it let us know as it scanned each page. So for our last scenario, I'll show you how to show each page as it's being scanned. So instead of showing the number of pages that we've just scanned, I'll show you that page as it comes in. So we do this a little bit differently. You know how to set it up. We call from ID async with that device ID. We're going to call is scan source supported for that feeder. We're going to scan all the pages that are on there. And this time, we're actually going to just break up the progress handling. We're going to create an operation object for scan files to folder async, and then we're going to specify a different progress handler called scan progress. And basically, that will get the result as it comes in for each change, And with that, we can just represent the very first file in that list, and we can display it directly on the screen. And since this is split up, it works pretty much the same. We return a result object, an image scanner scan result that lists the resultant files. Okay, I'll show you how that looks like. So scanners are very powerful. They have a lot of settings that are available. It's up to your app to make the scanning experience very delightful for the user. So there's a reason why certain users don't scan everything that they have, that there isn't a process or a workflow around whatever they need to get done. So make sure you keep the scanning experience very simple to the user. Don't merely expose the API to them. So this is each page as it's scanning, and we're scanning 3 pages. There we go. We just scanned 3 pages. It took at most 3 function calls for that to happen. So we can go ahead and recap what we just did. We enumerated our scanners using the device watcher. We got our scanner object, and then we scanned. We did 2 optional steps by setting the scan settings and doing a preview. And this was all possible by using the Windows.devices.enumeration for the device watcher. We called from ID async to get the image scanner object. Then we set the settings on that object. Then we called scan preview to stream async to do a preview, and scan files to folder async to actually perform a scan job. And that was it. Right. So let's just back up for a second. We all have documents. We all have photos. We have a lot of them. We have a stack of documents. We have a box of photographs. And they've just accumulated in our lives. Essentially, we still want to do the same things. We want to share content. We want to archive, modify, and extract. Now, so for some food for thought, your apps can now provide these files as an attachment. Your apps can provide protection, improvements, and build intelligence off of this with great text recognition. So in conclusion, the new Scan Runtime APIs make it very easy for your apps to digitally capture images and documents in the way that makes sense for your app. So we've laid the groundwork. We've connected you to every single commercial device since 2006. Your apps can be this anchor that brings the physical into the digital world, powered by the Windows Runtime. What new and exciting ways are you going to find in bridging these 2 worlds? What are you going to build? So we have a list of resources here. Please read our documentation, try our samples. If you still have any questions, we'd love to hear from you at wiainfo@microsoft.com. There's more information on the auto-configured scan source. And at this time, I will open the floor up for questions.
Are there also OCR?
Yes. Okay, so there's 2 questions. Do we support OCR? So in the Scanner Runtime API, we do not provide any OCR functionalities. And the second question was whether we scan to PDF. So whatever formats are supported by the device will be available through the runtime. Your app can supplement you can supplement the functionality within your app, so you can do some post-processing on that file to make PDF available to the user. Yeah, go ahead.
So I saw when you were doing your scanner and you're setting the size of the image to be scanned, How can I set that to be, for example, inches in some cases or centimeters in other cases? What's the actual units that setting is in?
Oh, that is, let's see, that was in inches. So we created a rectangle object. Let me just go back to that. That is, basically you're just setting a rectangle, and you can have that correspond to whatever you have on your preview panel. And I guess the question was whether that was represented in inches or in what units. Whatever the rectangle object supports, that's what we used. I am not sure about that particular API. So the question was, can I switch that to centimeters? So your app can do whatever post-processing, or not post-processing, pre-processing. You can, convert that yourself. That is not within the runtime API, or sorry, the scan runtime API. So that's outside of the scanner space. But I'm sure you can do some really interesting things there, like represent that this is, inches or centimeters on the screen for the user. Any other questions? Okay. Well, I will be sticking around, so if you guys want to chat. I'm sorry? Oh, I can't see anything, so go ahead. Okay, so the question was, do we support network scanners to connect from the Scan Runtime API? And the answer is yes. We do support network scanners, and the first thing you'll want to make sure is that the device is actually is connected, and we don't have a mechanism to connect your device. It should be available in the device manager under imaging devices, or listed under the devices in the modern PC settings. So once it's available there, you should be sure that the runtime can connect to that device. Yeah, go ahead. Okay, so we just had a question on whether, I guess the feature would be called auto cropping is supported. So that means if I have like I just showed you with the previous scan, I have a large area and there's only a small region at which the image is, and we want to see if the device can actually crop that out, that the user doesn't have to set that area himself. So if the device supports auto cropping, that is available. And there's two different modes for auto cropping. There's this single-sized or multiple images. So it is available if the device itself supports it. Yes. Any other questions? All right, I'll stick around so you guys can come up and talk to me. We'd love to hear your feedback, so if you could just evaluate this session. I'd like to see what you guys thought was good, what was bad, what you'd like to see more of, and that'd really help us out here. So I'm letting you guys out early just because I know this is the last session, and I'm the only thing keeping you from going and enjoying San Francisco or actually just going home. So thank you very much for attending.